Okay, let's start. So we should be able to describe at least 3 sources of GPS errors, okay? Identify 3 segments of global positioning system, describe technologies that enhance accuracy of GPS positioning, and collect a position data, okay? Describe the process a GPS receiver uses to triangulate its position, and identify some functions of GPS, is that okay? And basically, that's that. Move on. Right, so we've already touched on it. Space segment, user segment, and then the control segment. Is that also? Right, great. So the space segment is the satellites in the sky, right? User segment, the receivers. So you can have the mobile receivers, and you can have the receivers as used by surveyors. Is that okay? They mounted on tripods, okay, over a control, okay? All right, now control segment, or if you like, the control segment, yeah, the master control station and the monitor station. They've been set up on the ground to control it. So every satellite that's sent to the sky is controlled from the ground. Are you okay? All right. So remotely controlling the satellite by the master station is almost like the reverse of, we are going to talk about remote sensing. In that case, the sensors are up there and they are looking at something down. Okay. Control. So remote controlled. Right. The user segment. The military, yeah. Okay, how does the military do it? This is an interactive lecture with speed. Military, how does the GPS help them? What do you think? Yes? Exactly, because for the military, depending on where you are, your life has ended. Is that okay? They say they start writing a letter to your family. Is that okay? All right. Okay, such a rescue. Do you remember the Malaysian airline that was never found? Is that okay? All right, now how do we find it? You'll be shocked that without knowing your position, you can't find things. So when you can't find something, your socks in your own house, start putting your place in order and position yourself. Because in the clutter, you can't find your position. So you can't find the socks. Are you okay? Disaster relief. When there's disaster, Apiate explosion. Apiate. Why, you know the town yourself? Have you been there? Are you from the place? Okay, so I'm pronouncing like white. I'm sorry about that. I'll pronounce it Apiate. Apiate. Okay, it's actually, it has a meaning, isn't it? Apia is sitting here. Something like that. Yeah, normally it's Apiasi, you know, it's always under a tree, like the village was, set up under a tree. Okay, so in that disaster, we need to understand, the question is that, where were you? Now, I hear they estimate there was a certain number of people in that town, but when they actually did the survey and, interviews to find who actually was there or lived there, they have more than that number, right? Okay. So there's a lack of information. We just don't know where even the buildings were. Except Google must have captured it. So that's a good news. Are you okay? So we can always count the houses and start putting some numbers to it. Okay, how many people on average live in the house? Surveying. So GPS could help you get a position. How does GPS help us in surveying? It gives us one thing. What's that? Classroom. Today everyone's going to talk. Said, I'm coming to you. Yes. As a surveyor, what do surveyors do? They are trying to determine horizontal and vertical position of objects on the ground. Please always keep this in your mind. Okay? So that you know exactly when to get a surveyor if you are not one. So challenge this one. Are you okay? All right. So the GPS gives us information for that. Okay. Marine and aeronautical and terrestrial navigation. Yes. Why do you think when it comes to water, navigating the waters and also flying, yeah, aerospace, why do we need GPS?
As they will lose on the way.
We also need to know where we are. So I didn't have to talk about it. But please remember that you can have a question like that. And when it happens like that, try to sound a bit romantic. Why am I saying that? You see that the answers seem not to be quite clear. You can't really come out. Can you realize that? So next time you get questions like that, you need to come out and elaborate. Why do we need it? Aeronautical and marine engineering. Are you okay? Why do you need GPS? Why do you need position? You can't say, oh, because without that, they cannot find their place. That can be your answer in exam. Are you okay? So you need to kind of, write up, learn how to write. You are an academic institution. You learn how to. You can be in a normal organization. You don't have to necessarily. Okay, but in an academic institution, you learn to provide an answer which is concise. Are you okay? Remote control vehicle and robot guidance. Have you heard of AI? Automated self-driving cars. You heard of them? So how's the
AI
self-driving
cars?
Yes, Gabriel, he said.
AI now. This Benz, the Benz institution.
It can self-drive itself.
Yes, Benz. The latest model.
Do you have one?
Oh.
You watch it on TV.
and also for the television, they have AI system for the television.
That's okay. GIS. Okay, let's not talk about GIS. So GPS. Okay, satellite positioning and tracking. So even to track the satellite, we can also have a GPS on there. Can you imagine that? All right. Shipping. How do we determine when the ship will arrive at the harbor, at Taba Harbor or Takari? How long? I asked a student who was doing an attachment with my registered company. We don't have an office yet, but virtual. Now there's something called virtual attachment. You can be attached to the company without being there. You know what I'm saying? So even if you don't have an office and have a business, you can literally have attachment going on. You can make some money. Is that nice? All right. I asked him, how long would it take for you to get to UPS? UPS is University of Professional Studies. And there was a test for him. Is it okay? I was just trying to test his intelligence. And he said 30 minutes. I got there 10:15. That was 30 minutes after. And he wasn't there. So when he got there, I asked him, well, we agreed on 10:15. Why are you not getting here? And then he's like, oh, and I was like, hey, you can't talk like that. How do you determine how long it takes you to get to a place to have a meeting? Not sure. No, give me a concise answer. I don't want these brief answers. See, that's not romantic. Tell a girl, I love you. Okay, I love you guys better. Let's ask him, do you have dogs in your house? That's the answer you're giving me. Are you coming, Maxwell? Come on. Yes. Jonah? Yes. And I said, Jonah, I was kind of you don't make sense. Yeah, Jonah. How do you tell me that we can get to Kaswa, the interchange, and how long it takes so that you can settle?
By knowing the location, you can know the distance. So if you know the distance, you know that.
I like your theory. You sound like first. I want someone who can talk to me like a real person. Not to say persons are not real. Yes. How do you do that? So Google has given us the opportunity. Are you okay? To do shortest path. So we can do that. But how does it know? It first obtains your coordinates, know where you are, and then factor it into the calculation. Without knowing where you are, we cannot tell how far you get. And getting to know where you are is determined by GPS. Okay, so GIS. How GPS? GPS is all integrated, even though GPS is a system, it's also integrated into GIS. Can you imagine that? So system within system, please. All the things I'm saying, remember, you come in the exam, give me the right answers. So, okay, this time I want everyone to get 75 and above. Okay. All right, so recreation, people, we don't do it in Africa a lot, okay? But why people can decide that they're just going on a mountain, okay? And they just want to go and walk on a mountain. Can you imagine that? Okay, it's not something that black people do a lot, okay? So in order to find where they are, to get back home, they need to know where they are, not based on what someone told them. Are you okay? But then based on what? Based on you went. They call it, I think, hiking or something. Yeah. So you just go walking, just walking around, and tourists do that. Okay? They go on the Akajetu Mountain where you climb it. Have you asked yourself why people climb it? Okay. But for recreation purposes, GPS can be used. But I'm saying that if you get there, all right, and the person who is actually escorting you, they call them what? The guide. Mm-hmm. If the guide is your only reliable source of your location, you may come back without your head. We are at a place where people are doing ritual sacrifice. Don't rely on what people tell you all the time. Sometimes believe in the system. It's okay. Help you. All right. So what do you need as a tourist? Not to rely on local knowledge. You need your GPS. Are you okay? All right. Wait. So 4 primary functions of GPS: position and coordinates. Okay, and get your position and your coordinates. Thank you very much. You can get the distance and direction. Okay, between any 2 waypoints. That one is for, of course, aerospace. Are you okay? So how do you get to know waypoints? Pilots always fly from one waypoint to another. Okay, so yeah, so Roger, that's 186 degrees. How did they get a bearing? You get what I'm saying? To get this to 10 here, you need to know where you are. You need to know whether you are actually aligned on that course. Okay, that's waypoint. Travel progress report. Yes, traveling. How far have I gone? Are you okay? From my origin. Are you okay? All right, great. Accurate time measurements. GPS contain atomic clocks. Okay, which are extremely precise. Okay, all right. We've been built to be more accurate than the time that we are using. Can you imagine that? Okay, it's time that there was a time I checked the time on my. I so trust the time on my laptop and the time on my phone that I think a couple of days ago I was in the house and I was curious and I just thought I need to check the time. And when I checked the time, my phone's time and the one on the laptop were different by 3 minutes. Because we teach, okay, so you can't have weird enough, things like that happen. Time differences are not normally in that, But GPS allows us to have accurate time, okay? Better than the time you have on your tablet. All right, position is based on time. It makes sense, right? Why is that so? Why is position based on time? Can you imagine? Position is based on time. Can you relate it? Anybody? Jonah? How can position be based on time?
I think because at a lack of a different lack of time, we are moved.
Okay, sometimes I have to be romantic, but sometimes it's subjective. So now that is used in the calculation of coordinates. Is that okay? Delta E, delta N. Are you okay? See how relating time to distance and distance to position. Are you? All right. So let's understand that speed helps us to work out distance, and then distance helps us to calculate what? Coordinates. Please, if you don't understand, tell me. I'm not in a hurry to get it. Are you okay? Please, but if you're okay, let's move on. Any question on that? Are you happy? And I'm sure you are wondering, why am I saying that? Yeah? Okay, that's because GPS is simply send a signal. Are you okay? Let's bring on. So, radio waves travel at the speed of light. That's a fundamental thing, okay? So if radio waves are traveling at the speed of light and I can measure time very accurately, I can literally find out the time I sent a signal, the time it reached the receiver, then work out the distance. Are we happy?
Yeah? Yes, sir.
That's it, we're done. So the distance T plus 3, means that we shifted by 3, and then we can work out the distance. Okay? All right, so what GPS does is that it actually generates a code, and the code is called a pseudo-random noise code. Okay, so it contains a lot, all right? Pseudo-random noise code contains a lot. Okay, let me share my screen again for those online. I want to show you something that we'll do some reading here. Okay, so basically, there's a navigation message. The message contains the time the signal was sent. Okay, the message also contains the health status of the satellite that sent it. Is that okay? Right. So I once went to hospital, and then whilst I was talking to the doctor told me that you have not been well. Doctor, you know well I've come, and the doctor is telling me what. So do you think the advice is even given? He's in the right frame. What I'm saying is that once we receive a signal from a satellite, we need to know if the satellite qualifies, are you okay, to help us compute our location. Is that okay? All right. So there's a whole lot of calculation that the calculation itself is very simple, but there are a whole lot of errors that can be, associated with it. Okay. So basically, when the GPS receiver requires a GPS signal, it examines the information within it, the navigation message. Is that okay? And then it tries to now work out, the time difference. All right, and then it calculates your precise time and work out the time difference and work out the distance. Are you okay? Based on speed, time, relationship. All right, let's move on. Are you still seeing my screen, those online?
Yes, sir.
Okay, great. So time. How do we know the time difference between places? Now that's the topic now. Quick one, let's go. What's the time between Nigeria and Ghana?
1 hour.
1 hour. What does it mean?
So you move from longitude.
What time is time, isn't it? Isn't it? Yeah. So I've been talking to a professor friend in Germany. And every time we talk, in fact, there are times I miss the whole meeting. Why? Because the time difference is 1 hour. And so I'm thinking 8 o'clock, then we go, hey, I didn't see you, what happened? And so I have to get used to the different time. Now, I said, why don't we all agree on one time? Because the differences make, that's significant, isn't it?
I said, the changes, the natural changes, day and night.
Say it again.
The natural way of changes, day and night. So 6 p.m.
So exactly, that is why it makes sense, because naturally, before we came out with these concepts of time, there was a way to determine time based on sometimes putting a stick into the ground and then watching the shadow. Then you get to know what important time point in time that's of interest is what? Midday, 12 o'clock. And in Kumasi, they used to have a siren that every 12 o'clock that goes. I don't know if Accra, city of Accra. I'm talking about Greater Accra. If they also have it, they'll have it at the post office somewhere. So when it's 12 o'clock, something goes on. And I think way back in the day.
We use sound of animals.
Sound of animals to determine whether it's midday.
Yes.
Okay, that's an interesting one.
At 12 o'clock, you get
Obreko, I know Obreko. Obreko, what's the English name for that? For the sake of our Nigerian friends. Obreko, what's the English name? Okay, send him the P dictionary. Okay, let's check.
And one is 3. The bush one.
It goes. Chris is a great resource.
And
that's good.
So
What about them?
Hey, are you taking over?
No, don't come see this.
No, the boja is firefly. Okay.
Yes, but they also make noise.
No, yeah, I just want to understand what you mean by the boja. The same boja like that. Firefly. Have you seen a firefly?
Small birds.
Now, I have seen a firefly. No, these days you don't see firefly.
You see.
As the city.
Because where you are.
Hey guys, I'm enjoying this. I'm enjoying the interactive nature of the class. And when we go to the exam, do it the same. Question 1.
Can you write
What I'm saying is that it's in the same spirit you should be answering your questions. It should be full. Are you okay? You see how we enjoy that. So Firefly, it controls time, eh?
Yes.
That's good. That's good. Okay. Okay, but have you set up, anybody here set up a Zoom meeting before? I'm a lecturer, so I've always set up Zoom meetings. Anybody here else set up a Zoom meeting? Created a meeting, scheduled a meeting, anybody here? None of you has really scheduled a meeting for other people. You've done it before. So you see that there are different time zones.
Yes.
You have a list of them. You have universal time. Are you okay? So universal time seems to be like the reference time to which every other time is compared. Are you all right? Yeah, so the universal time, UTC, is close to the GMT, but it's not. Sometimes there's a variance of 1, plus or minus 1.
Okay, that's why sometimes we and UK, there's a change. If we are on the same longitude 0,
yes.
Sometimes UK
they just do a plus and do a minus. You see, they keep on doing plus and minus, isn't it? So what if they forgot to do a minus in a particular year? The time will be up. But it doesn't really matter. I think we have created this concept. Okay. We have created this concept. If the F ceases to exist, these things are all the F has to be there for you to have these concepts. Do you get what I'm saying? That we have to find them. Right now, JMT, Greenwich, is a town in London where a certain longitude passes to the reference longitude, 0 degrees passes, and you can go there and they'll show you the exact line that has been set out by surveyors using astronomical methods. Are you okay? It also goes to there, but they haven't really set it out because the other Institute of Surveyors were trying to set it out and make it a tourist attraction. People can come and look at the 0 degree. Are you okay? Going to that place. And they should do it. Are you okay? I know the ideas are not there. But let's understand that there is also military time. I like the military. Are you okay? I like the military. Military, they have their own code. Are you all right? They have their own time too. Okay?
Why do they always prefer
the military? They have even a way of writing their time in a certain sequence. There's no column. No, we are 2. Say it again.
700. If it is 535.
That's 170. But you see, when you actually write 17.00, that is wrong. Okay. So 1700, isn't it? See, they are very intelligent people. Everyone should go to the military, but they will beat you first. Okay, but it's important for us to recognize that GPS and time have a relation because it needs the accurate time to what? Determine the position. This is all, that's the reason we are talking about time. Okay. All right. So why can't one satellite fix your position? It's technical drawing here. So if I have a satellite, why can't my receiver is on? Why can't I fix my position with that? There are a lot of inaccuracies. So just trying to fix one position like that. So what you want to do is to have probably a second one. And when you have a second one, so the first one defines a circle. The second one defines another circle. And the intersection is supposed to give you the actual. All right, great. What if the intersection goes more like this? Then all these are possibilities. I get that. So they are called probabilities now assigned to where you are likely to be. So that little error could be just 100%. You couldn't be using that for engineering works. Okay. All right. So ideally, you want a paired satellite. And with that intersection, bang on, that's just one single point. Mathematically, right? So you can work at the geometry and fix a location. This is why you need a minimum of 3 satellites or more. Once you have more, you can solve from what? You can have what we call the observation equation and then solve for it. Okay, so GPS wasn't like this some years, but it's very important for all of you to understand that the world's powers are always fighting for, everyone to know that they are there, are you okay for power? You get what I'm saying? So there used to be what we call the selective availability. So selective availability, US was thinking that, okay, we don't want anybody to access the GPS. We put an error into it. You see, receiving it there, like radio said, you remember when the TV license, do you remember TV license? And if I don't remember if my dad ever paid, but if he was arrested, I'm sure he would pay. But why did we never pay TV license? I think they still want to take it.
Yeah. They raised the issue back.
Yes. You are fighting against how many people? The population.
30.8.
Yeah, but with good management, you can collect it. Is that okay? Like we are taxing you for your mobile money. Is that okay? Please keep quiet and let's tax you. Wait. Yes. So selective availability is probably the reason the other countries thought, let us launch our own satellites. Nobody can stop. But as for space, it's for all of us.
Americans put errors.
Yes, it's called selective availability, where you fix your position to tell you are here, but you are not really there. It will put you in the lake. So when you launch the missile, I think it's going here. You blasted your own house. Are you here? So basically, it was there, but it was stopped at the year 2000. That thing was cancelled. But it had to be cancelled. Someone else will fix their own location. Anyway, so basically, there are errors. Okay, there are errors. Selective availability is more like a gross error. Okay, like what's a gross error? Extremely not negligence. Opposite. It's huge. Gross.
Gross insubordination.
Exactly. He hasn't received a letter like that. For leading people, influencing people to strike and protest. You are a good man, but the letter you receive, you see the Labor Act. Now you know that Labor Act is alive. Satellite clause give error. Is that okay? Orbital errors. Orbital errors. So the orbits in which the satellites are, they have to stay constant. Don't forget we are working maths. So once this distance here is not looking okay, then you know that there's a problem with your intersection and your actual triangulation. We call it triangulation. All right. We can have tropospheric errors. Are you okay? Troposphere. Okay, what's the difference between the ionosphere, the troposphere, and the atmosphere? Are we civil engineering students here? Okay, great. Are we really studying the civil engineering? Okay, do we understand the differences? Our environment extends as we go up. Are you okay? From the atmosphere. Are you okay? Then it goes on and on and on. Are you okay? At different layers. Okay? Please, you need to understand all these things. All right, so we can have the troposphere, the ionospheric errors. Why? Because the signal is traveling through that medium and it interacts with it. There is dispersion, there's absorption. Are you okay? It's a signal. Have you seen a signal before? Have you seen a radio wave before? They are not visible. Are you okay? They are within the electromagnetic spectrum. We'll touch on it again quickly. All right, that's what we call the multipath. So multipath, we don't see it these days because of digital TV. But when in the days and the era of Etikoko TV, and for our Nigerians, Etikoko means what? What's the name for it? What's the English name? This thing here, you see my long one. We used to have this black and white TV, which was in flats. In Ghana, we call it Etikoko TV. It's all right. In that era, where Said wasn't born, clearly. Okay? You could have what we call shadows in the imagery. The shadows, do you know what caused the shadows? Anybody who saw these shadows? Let me tell you. You have the signal coming to your house, all right? The antenna is receiving it. But it got reflected off some sort of aluminum something in your area. And that one took you. Okay? Or your own antenna has now produced two signals. So there's a shift between the original signal and the second signal. So that caused that. So sometimes by just orienting your team. This is in GPS, that error is called the multi-path error. The multi what? Multi-path. So you have so many what? Paths. Okay, you can have user error. Users can take in alcohol and start measuring. And they'll be fired at the end of the day by the manager. So they don't collapse it. Okay, errors are cumulative and they are, of course, increased by what we call the position dilution of precision. Okay, so we'll learn about that. We'll touch on that quickly. Please, you can ask a question as we go. As this is not really, this is like a story I would tell, isn't it? I hope you follow it. It's quite technical too. Is that okay? Don't think, oh, I get it. Okay, great. So that is it. You can see there's a diagram. Those who are online, it's a diagram. So of course, that's it. There are also errors. There's a dilution of precision, DOP, yeah? Position dilution of precision. There's geometric position of precision. We have vertical dilution of precision. Are you okay? We have time dilution of precision. Okay? Literally, it's just referring to the errors and how they are affecting your precision. And where is that music coming from? It doesn't happen sometimes. So can someone shout? Can someone shout to him guys? Okay, I think we can't do much about it. Okay, let's carry on. So we have all these, okay, measure of the precision. Are you okay? So the bigger the precision is, then it's like, it's not good. Are you okay? To have the geometric dilution of precision, GDOP. All these affect the way the signals are generated. Okay, so yeah, you can have poor satellite geometry and then good satellite geometry. The last thing you want is all the satellites are and you are trying to fix your position there. It's something not geometry, isn't it? You end up with some funny ways of that's exaggerating having the satellites too close together. So we want them quite. And the receivers have functionality that allow you to measure that. Okay, at this time, you need to just understand what animal the GPS is. If you don't get that, this lecture wasn't worth it. Because I think I'm talking about too many things. There's differential GPS where we can correct for the errors, okay? And then send the errors to any other receiver within the area, okay? Or for our project, we could actually work out the errors and then supply it to every other place that we use the receiver. Are you okay? So we have real-time corrections. Are you okay? All right. It's called differential GPS, okay? Right. So we can make those corrections on the fly. Any questions, guys? That's it for GPS. That's what I want you to know. Any questions? If I went fast, which sometimes some students confess, they say, sir, you were going too fast. But I asked myself, why didn't you see the only way you stop someone from going fast is by saying it, isn't it? When I was coming here, I think yes.
The satellites interfere out there.
Put it in the right, rephrase.
The statement was many are satellites out there.
Mm-hmm.
Is there any cases that
of course, there are authorities. The good thing about the world is that we have authorities, okay? Global authorities for every area. Environmentally, you can look at the IT, okay? Internet like this is regulated, okay? You just can't get up and do whatever you like. So all these are regulated, okay? You can't just get up and do anything. You just launch a satellite. You launch a satellite to be detected. Right now, if you like, just go into the bush somewhere and launch a satellite.
It will be seen.
And if it gets up there, of course, you know the studies that are going on. So all of you, I encourage you to further your studies. You want more Africans off record. Off record. Okay. Please, let's be more interested in I'm going to talk about remote sensing. I'm repeating it because I'm recording. It's reached a stage where I'm literally thinking people are going to lose their job. Literally, you can map. You don't have to be.
You sit in
You see these footballers play, watch Champions League, and the player is being tracked by a certain symbol or icon. Those things are not easy as you think. There's a lot of algorithms.
Identifying the movement of the.
Exactly. So technologies have come to change the way we do our things, and you need to be abreast with it and understand how it works. If you don't, you'll be part of the old school, and you'll always be in the bush. Are you okay? I'm saying that for a certain effect. When I finished my service so many years ago, and I was working in a company, immediately I got there. There was a friend there already, and I knew Excel. I was that good with Excel, still good with Excel. And really, the boss realized that I could do the Excel. That was it. I wasn't going to the bush anymore. So I'll just be in a condition doing calculating. The difference is that I have learned a new way of doing things. So, because previously they were manually doing this. So I had come in with a new idea. When you go into a company and you cannot change the way things are done, you will not be seen. You'll be one of the people that will be sad. If you cannot even recommend to your boss that, boss, we should keep doing this. You always think you're a valuable asset. Not he always calling you and telling you what to do. You shouldn't be called and told what to do. You have to, and remote sensing has gotten to that point. There is a new technology in artificial intelligence that allows you to literally see an object and then convert it into a digital format. Not just take a picture of it. Your phones are able to tell that your eyes, have you realized that it's always doing something around your eyes? Sometimes it sees your face. I think those using your phones, facial recognition. All these are serious algorithms that have been built based on probability and statistics and linear algebra. Are you with me? All right, off record. So remote sensing, what do you think it is? What do you think? Boss, how are you? All right, just hold on a second. Think about it. I'm coming back to you. What is remote sensing? What is remote sensing? What's remote sensing? So remote sensing is different from GPS. They all make use of what? Satellites, okay? The GPS satellites are sending signals about their position and sending the information message, okay, about their health and about the time a signal was sent. Are you with me? All right, in the form of a code, all right? The remote sensing satellites carry a sensor, okay? Example of a remote sensing satellite will be a camera, okay? But the camera contains more channels. When I talk about channels, color is broken into 3 channels. You have R, G, B. Are you okay? Just red, green, and blue. These are the components of the color, every color you see. So it doesn't matter what color you look at, it can be broken down. And there's a little amount of every single one of these RGB. Okay? All right. So if I take a camera and I take a picture of you, everything I'm getting is a mixture of these. Okay? All right. So remote sensing satellites now simply measure from not just the RGB, but try to also measure from what? Other, regions in electromagnetic spectrum. Okay? What's electromagnetic spectrum? Can you mention a few things in it? Physics students, please wake up. Electromagnetic spectrum, what's in it? You can't sleep. The question is coming, you can't sleep. The question is coming, yes. Once the question is coming, wake up. Otherwise, there's a funny joke of a guy who was in church and then he slept hard, and at a point he heard the pastor saying that, stand up. There's only a stand up here, so he just stood up. Then the pastor said, clap for him. Not knowing that they were looking for who wants to give $1,000. So don't sleep. Is that okay? Before you go and write in the exam some funny things.
So he did not hear the $1,000.
No. Yes. So let's carry on. Am I talking to someone? Okay. So remote sensing works like that. So it can measure from infrared. We have what called the near infrared. So red, the color red. Have you heard that when women wear red, you see, Christ is wearing red, it doesn't mean anything to us. But when a woman wears red and walks into this place, you understand what I'm saying? Everybody's going to be like, watch out. Okay? Those who are married, no more. We'll talk about that later. But basically, red is close to near infrared. It's okay. And we don't call it infrared for nothing. Okay? And so a butterfly is likely to probably fly towards Christ, not Chris, because his color is a bit pale, or it's a certain color you're wearing. But basically, what I'm saying is that remote sensing can detect more than just what we see. Are you with me? So the US can know that there's an activity going on underground simply by sending a satellite that measures the surface temperature. Because there's an activity underground, you know that from the imagery that something is going on. Are you okay? All right, great. Remote sensing has so many applications. I just can't stop talking about it. But what is it? Remote sensing is the practice of deriving information about the Earth's land and water surfaces using images acquired from an overhead perspective by employing electromagnetic radiation, okay, in one or more regions of the electromagnetic spectrum, okay, reflected or emitted from the Earth's surface. Okay, so we continue in Jeffrey, hold on for me. I'm concerned, class. You trying to tell me that you are so on top of it, Floyd, Maxwell? What in your mind, what do you think I'm talking about? A satellite up there taking a picture. Why? Why should you have a satellite in the sky taking an image on the ground? And how do you think it's going to work? In your own words.
How is it going to work?
Yes. What's the idea? I'll just give you an introduction to what remote sensing is.
This is to know the activities happening there.
To monitor activities
On the ground. Yeah, we're always interested in monitoring. That's true. And as engineers, we always want to measure, isn't it? Okay, that's great. So the camera is one of the typical sensors that you have on the satellite. So the satellite itself doesn't do any measurement. It doesn't do a measurement. Okay. What does, Jonah? What does the measurement? It's not the satellite. Side. It's not the satellite that does the measurement. What does the measurement?
Sensors.
It's a sensor. If you've been driving one of these latest cars from the year 2000, you know that it senses from tomorrow. I'm buying one sensor, 250 Ghana. When you look at it, you wonder why should this cost you? But that's what controls a lot of things. The sensor, are you okay? Senses. Okay. What is it sensing? What is it sensing? It's sensing what? Electromagnetic radiation. You're not using the technology. Okay. How do I know I'm sensing the right energy, electromagnetic energy or radiation? This is physics we are talking about. So we are refreshing and we are learning. Yes. How do I know if I'm sensing the right energy? How do I know? I know I'm sensing the right one because you can't take this and take a picture with it, can you? Can you take this and use it for a picture? What is it good for, this? What's this used for? Internet, right? Can you use a TV to receive radio waves? Am I talking to you? Are you understanding the point I'm making? That depending on the sensor's qualities, you can detect the particular electromagnetic radiation. Please, this is it. Please, I'm the one examining you. So there's a reason sometimes I teach in a certain way. You see me gesturing and all that because I've marked scripts. So please, I'm tired from already. So please, I want you to understand. So I know the kind of answers that I will get. Someone will give you an answer off. You ask yourself, was he not even there? So please pay attention. It's okay. All right. So we are measuring from a certain range of values. Okay. Anytime you measure from a certain range of values, mathematically. All right. So don't forget, red, green, blue, their values. Their color values. Are you aware? Go online and look for the hex values, hexadecimal values of colors. They relate. Okay? Sometimes you take a picture, their values. To your smartphone, their values. To you, it's a sexy picture. Are you with me? You are worrying yourself. They are numbers. Okay? Oh my God. So when our ancestors come back to our present age, they'll be thinking a lot of people are mad these days. Some things we're doing don't make sense. Have you seen someone walking by the roadside and just laughing? All right. No, you understand what I'm saying? So remote sensing is like that. Okay, we measure from what? Electromagnetic spectrum. And what are we measuring? Electromagnetic energy, wave, or radiation. Radiation, example of radiation is what? X-ray. So when you go to hospital, those who were not educated when in their time, the old ladies and old men, they always say, I want to do what? Take a, the doctor say I should go and take a photo. They are not wrong at all. You see? Of course, that's what they are going to do. It's like taking a photograph, but this time, the energy that is being collected is what? Something else. It is X-rays that are being reflected off your bone, isn't it? Against a certain thing that they put under wherever you are doing this. Understand these things so that you can know what you are doing. Sometimes, as a scientist, you need the science for your own self. Okay, great. So we can sense from different regions. The visible region, the infrared region, we also can sense from the microwave region. Is that all right? KKK. Now, depending on the object, certain radiation and wavelengths or frequencies, wavelengths, are you okay? Actually gives what we call a beta reflectance. Okay. We are ending this in 10 minutes. Wow, this session has run for a very long time, isn't it? Okay.
Yes, sir.
Yeah. Listen to me. Depending on the object's characteristics, certain wavelengths have certain reflectances. What does that mean? Think about taking a picture. Are you okay? Depending on the object, can you give me an example? Depending on the object, the picture comes out a certain way. Anybody gives us a particular example. I want to use that to explain to you what we call reflectance. Are you okay? The reflectance of an object. It indicates how much energy will be absorbed and how much will be reflected back to the sensor, the measuring of the sensor. The biggest source of energy for remote sensing is the sun. Okay? So right now, our earth is illuminated, isn't it? When you look at the window, it's beautiful. Is that not so? So if you shut the sun right now, you have what? Night, all of a sudden, yeah? Eclipse. Okay? The eclipse. Remember? Another was on TV telling us about the eclipse. Then she was fired later on. Yeah? Okay, guys. So the reflectance depends on the object, the characteristics of the object. Okay. So basically, we can have different types of objects having different what? Reflectances. Some of the radiation from the sun to the object are reflected. Are you okay? Some of them are absorbed. Some of them are scattered. Are you okay? So depending on the roughness of the surface, you can have some scattering happening. So the signal hits the surface instead of it to go back to. Okay, you're taking a picture. When you're taking a picture, you are working very well with the sun. Are you aware? And if you have a flash, then that supports. So in the night, you have a flash. Your flash then becomes the source of energy. What is happening with your flash? Hits the object, comes back. Guys, I'm scared. Why am I scared doing this lecture? I don't know whether you get it or you don't.
Yeah,
You get it. Are you getting it?
Yeah.
It's not taking a picture. I'm talking about remote sensing, you know. But I'm using it as an analogy. Do you get it?
The energy that the sun gets from the light, the picture becomes that energy can be reflected.
Exactly. So what it really means is that when you take a picture, something is hitting the object and you are measuring it. That's what is happening. It's not like I'm taking a picture and the camera is so good. Without that energy, you can't record, even if it's iPhone, what? 45. Okay, guys, so basically they say, ask me questions. If you don't ask me questions, when you ever see a question in the exam, don't give me the wrong answer. I'm sure you will get a good reward for your answer. Please, you have a question or you think you get it. There are lots of, I'll give you a lot of examples in the slides, those watching online, that make you love remote sensing, okay? In this particular image I'm showing right now, it's parts that are, please, when I'm talking, let me know. In the picture I'm showing, the image I'm showing, there are parts that are red. The reddish areas are actually vegetation, areas that are vegetation. There are 5 vegetation, okay? So the sensor is sensing areas that have vegetation, okay? And you can have other applications, but
yes.
to find it, because the world is so vast, and that's something. The world is so, the surface of the earth. You can just imagine. So with something, in fact, the oceans are so huge. Apparently, 70% of the earth's surface is water, right? So if you drop something in it, yeah, it's not going to be easy for you to find it. It's as simple as that. That's the answer. It's got nothing to do with engineering. It's just got something to do with the space within which you are searching. It's so vast that you just can't find it. And so your question, I think your question has something to it, which I like. And I think it is that if we can easily map the earth, we should just map it quickly and know exactly where places are. But I see when, I think the accounts have say, they were joining on you know what it means? It means like, if you hide and you know where you are hiding, we have to find you. You understand that? Where an airplane disappears, we just don't know where it is. But if there's a GPS in it, we should have known, isn't it? Is that not the point? Okay, so what do you think we just can't find it?
But planes are connected with.
They are.
Yes.
But after some time, do you think your tablet is going to be on forever?
No, I'm talking about black.
The black box, that's a GPS. The black box is not a GPS receiver or transmitter. Remember, so we have GPS receivers. Okay, they have to still radio their location. Said, are you with me? I may know my location, but I have to send it to my mom. My mom to know where I am now. Are you happy? If I don't send it to her, I know my location, but I'm missing. I'm lost. Are we on the same page?
If you don't send it, yes, sir.
I have to send it, yes. So in differential GPS, we send information through radio. So the work is being done here, then we are sending corrections to it. So radio plays a role in some of these things. Say that again.
So what you're saying is that
of course, human beings, we are really, really far from ideal. And you'll be shocked that as of 1940s and 45s, World War II or something, I mean, it's a lot that have not been done. Computers, hell, computers. You as you go back just 20 years, you realize computers were not that powerful. Even your watch, your digital watch had more memory than the whole computer. 20 years. So if you are 20 years, it means you are not even too far from that. Are you okay? I bought the first computer in our house and we threw it away only last month.
Yeah.
Because it's just garbage. It doesn't have. What point we are making is on location, being able to map the world. Are you okay? That's the kind of question you are going to be asked in the exam. That you have a project area. Are you okay? Why should you be mapping using remote sensing or be mapping it using GPS? Are you okay? And you should be able to understand how these things work and why you want to use one or the other. In an emergency, for example, we need engineers. Are you okay? In an emergency, in fact, the whole NADMO thing is an engineering something with soldiers. Are you okay? That's what emergency is about. It's not about, of course, military, some of them are, we have medical teams, they are soldiers, okay? They can shoot all right, but they do, the whole military thing can solve an emergency situation, the whole military. Are you okay? You don't need them. But that is why you are being trained. So when you ask a question, try to look at it from a certain angle. Are you okay? How does it work? Okay. For your project, the project that you're working on, there's something with images. I think no one is even thinking about it. Maybe you're hungry like as I am. Oh, you have a question?
Yes.
Okay, go for it. Yes.
When remote sensor takes the picture, does it give it as it is? So because you mentioned of the colors, or give you some colors, they can represent the
Vegetation.
So
that's a false color. So like I said, images are really numbers. Are you okay? The colors we give to it are actually our own way of symbolizing. Are you okay? Every image is made up of these squares called pixels. Are you okay? All right. So for remote sensing, the same thing applies. The whole area is literally subdivided into squares. Okay. And then the squares are like we are sampling on the ground. So when I take a picture of you, I'm literally sampling you. Now, based on the resolution of the camera, based on the size of the squares, I do get an accurate and very refined image of you because I divided you into millions of squares. That's what happens. Hold on, let me finish. You can ask your question. Hold on. So the device, the resolution of the device determines the accuracy and the representation. And for remote sensing, we are talking about the pixels, and the ground sampling distance relates to the pixels. So the pixels